Hey guys, Cam here at the Battler Workshop and welcome. Well, it's been a little while since I've had a video up. Today's video is going to be on doing a repair job for a Colchester Lathe. It's the clutch drive assembly. A good mate of mine had tried to do some repair work on that and got himself into a bit of strife, and as a result we've got to make up some parts for that and do some of the initial repairs that we're going to be done on it. So we'll make a start on that today. The other thing I've got too are some stickers. So I've got a couple of stickers. One is from Paul at Haxby Shed down up in the UK. I'm sure if you watch my channel, you watch Paul's channel. He's very easy to listen to. Very methodical way that he goes about explaining what he's doing, and it's very good. I enjoy just sitting down watching Paul going about his work. And he does a whole range or a whole variety of different things in his workshop. So I'll leave a link to Haxby Shed down in the description, so please get over and have a look at him and support him. He's well worthwhile. The other one is formerly Tommy Gunn. He sent me some new stickers for Tom Make Here. So we haven't seen Tommy for a little while. I think the last video he put up, he was doing his rotary brooches. He's doing some pins, I think, for some crane assemblies and lining his workshop, and I think he's doing an extension on his home, so doing a bit of carpentry work. So he's been pretty full on at the moment, so obviously a lot of content coming out of there at the moment with all the other activities. And the other channel he's got is Was Make Here, which is more around doing restorations of old tooling. So once again, I'll leave some links for Tommy's channels down in the description. Alright then, let's go and see what we can do about this clutch assembly for this Colchester Lathe. Okay guys, we've got an interesting job here, and this is from a mate of mine. This is off a Colchester Bantam. This is the clutch assembly, and they've got all the clutch plates inside here, but we'll pull that out in a minute. We'll go through what the original problem was, and that was the drive dogs on the end of this spline shaft here had all rounded out. So obviously it's been engaged or half engaged and then driven, and over time it's no longer driving. So the original problem was, or the issue was, to get these built up and then file back or machine back to suit the dog that they fit into, the female half. Now he's tried to press this out, and there's been a circlip in here that he didn't know about, and it's put a fair old load on this clutch assembly, and as a result it's sort of exploded into a 1,000 bits and pieces. So we've got all the bits and pieces here. And there's the top bit there. So the first order of business is going to be getting what's left of this out and making up a new one. So I don't know what this is called. It's in cast iron. It's got little bushes in here. These look like oilite style bushes in here. So I'll make it up so that they fit back in again. I'm going to make this up out of steel. So there's going to be a little bit of work in this one. But what I need to do first of all is to get this assembly out so that I can start doing some measurements, and we can get that on the go. You can see the clutch plates there and the engaging dogs that run that. But we've got to get that cast iron hub out of here. So, not having any drawings, we'll try and have a bit of a go and work out how that comes to pieces. And that's the issue. And look, I defy anyone to tell me that if they haven't had a go at something and unsure of the sequencing of something coming apart, that they haven't done some damage in pulling it apart. I certainly have. I'd like $1 for every time I have over my career. But it happens to all of us, and unfortunately it's happened to my mate. So we'll see if we can get him out of strife and get this back together again. Right, so there is a circlip in here, but this circlip would be covered by this entire face, so there's no way in the world that you would be taking that circlip out with this in place. So let's have a look at the back end. Now, just looking in there, we can see a seal in place. We can see that oilite bush, and there's a couple of holes here, obviously, for a dog to maybe spin this out. So I'm thinking this might be a nut. So I'm just going to get in there with a little pin punch very gently and give that a tap and see if that undoes. Once again, we don't know whether it's going to be a left hand or right hand, or if it is actually threaded, and it may release it, but let's have a bit of a look-see. Just feel it out. So that's spinning with that. I'm going to look at a way that somehow I can lock that in place, and then we'll give it another go. Alright, so I've got that really badly busted up shaft gripped in the 3-jaw chuck. Don't you love that? I didn't have the camera running, and we sort of started getting this thing to move. So again, we're punching down into it. It's come free off the chuck jaws again. And it has started to move, but it is going to fight us all the way, I think. So I'll let go from the jaws, but I'll still get it into a position where it does tend to lock it, so I can get the screw out. Like I said, I think this is going to fight us all the way. I don't know if that hub's moving or whether the screw's actually coming. Ah, there it goes. Beautiful. Alright. Now I'm hoping, it's actually sitting on a bearing, I'm hoping that I can set that up in my arbor press and I can press that out. Right. Let's go and get set up and see what we can do. Alright, I'm sorry about the crap angle for this, but I've got so much junk piled up here from doing that civil works that I did. Oh, jeez. I shouldn't have been worried about it. It's just falling out. Alright, let's have a look at what we've got. So, that's our piece. That's just falling out quite nicely. That's our locking nut. If you have a look, it's got a slit in it. It's very hard to see, but there is a release nut just here, a release screw just here, where you nip that up and it locks it onto the thread. So that was why it was sort of fighting us to get it out. I didn't see that, didn't know that was there. And once again, when you're going in the dark, you're only doing your best. If we had a drawing to work with, we'd see that's straight up exactly how that's going to work. So the next thing I'm going to do is get all the broken pieces all pieced together, and we'll do a drawing. So I've got a little bit more work than what I first anticipated in this. We've got a little bit of threading that we have to do here to fit that nut back on again. We've got a seal in here, so I want to get that seal out and have a look and see if there's a step in the diameter. So we'll work that out. We've obviously got this bush, sintered bush inside there as well, which appears to be like a sliding fit. I don't know. It looks like there's an oil hole or an oil groove there that I'm going to have to include in this somehow. That's going to have to be put through with a very fine slot drill, I think. But we'll get this together. I'll get a drawing and we'll come back and show you what we're going to be doing. Righty guys, so I've gone right over this and I've created a drawing. And when you get pieces like this, and I've done this many times, a customer comes along and something's totally shattered. You've got to look at what you've got and what you can work with to try and come back to what the dimension sets would have been. Now this one is fully imperial, and you'd sort of think that everything's going to be fairly much nominal on imperial size, and that's the case on this one here. So for example, to get the OD of this flange face. Obviously we haven't got a full flange face there because it's been shattered out. We can just take a measurement from the outer diameter here, which is bang on 2 inches. We can zero that up, and we know the distance from there to there is 22.19, and that actually worked out at 4 inches when you take it OD to OD. It has 3 holes that appear to be evenly spaced, and once again we can measure from the outside circumference to the inside edge of the hole. We can measure the diameter of the hole, halve it, and come up with a position for that particular hole, and that worked out exactly 3 inches on the PCD of that hole. Once again we can measure the OD of the chamfer, and we can come up with a size for that one as well. I've been able to push this back on again. It's quite a tight fit in there. You can sort of see where it's cracked through, but I've been able to get a height from that. It has an oilite bush in here, or a sintered bronze bush. This one here is actually spun in it, and it's quite loose now. So the plan is I've got a bit of good bearing bronze here, so I'm going to make up two new bearings to go in here with the new section we're going to make up. A couple of other little anomalies I found on this, and that is, try and get it up there, see if we can see it. We can see some tapered reliefs in on all the shoulders. A bit hard to see that one there, but there's a tapered relief in here. And the way I see these are for the relief of the radius on the bearings that fit up against here. Bearing does push up against this face here and does push up against this face here. And the way I've come to that conclusion is you've got to look at how this thing would have been made back in the 1950s, and it would have been probably done on a turret lathe in a production sense. And this would have been a rough casting when they got it and set up. It might have had a bit of extra stock on here to hold it in a chuck, but they would have had all of their stops set up for the various operations coming up to these shoulders, and obviously all the stops set up for the diameters as well. And I would assume that they would machine all the diameters and then come in with a facing tool, and that facing tool would then come in and then stop at a set point, but it would also cut in that relief as well. So facing here, facing here, facing here as well. So that's the way I see it anyway. So we're just going to make these radiuses in here just a bit smaller than the radius set on the actual bearings. So from that, I've just done a quick drawing. It doesn't take very long at all. We do have an oil hole coming through here on a bit of an angle, and I've got all the datum points to put that together. We can actually see that on the actual part. You can see the oil hole going in there. And it does just chip onto, probably hard to see in there, but you can see it just chips onto the onto that oilite bush when it goes through. So we'll have to put that hole in once I get the bush pressed in for the one that I'm going to do. Now the seal, I had to punch this seal out, and it was terribly embrittled. That the plastic was very, very brittle on this. I couldn't get the exact seal as far as the width goes. This is 5/16. The one I've got is a quarter. So I don't think it's going to cause us any issues. It just means it's going to press in a little bit deeper. I do want to keep the dimension sets exactly the same on this all the way through, but as I said, I think when you press that seal in, it's going to sit a little bit further below the surface. I don't think it's going to hurt us in any way, shape or form. All right, so we've got our drawing, we've got all our dimension sets. I haven't put any tolerances on here. My aim is to use my gut feel and also the dimensions that are verbatim on the actual part. And I'll be measuring off the bearings as well to get the right sizing or the right clearance fits for this to fit together again. We do have a thread on here, 16 TPI, to match that locking nut. But other than that, I don't see any major hurdles on this one. I've got some stock here that I will cut. Fair bit of machining on this to get this knocked down. So let's get that material organised, and let's get over to the bandsaw and Alright, that's the roughing out finished on this side. I'll set up, we'll do a roughing on the bore, and I'll let the whole thing cool down. We'll turn it round, part it off to length, and then we'll start doing the roughing out on the other side, and we'll get set up for the final finishing. But I must admit, I love having the power of this bigger lathe. I'm taking 4mm off the radius, 8mm off the diameter each cut there, so it's great to have that grunt behind you. Alright, let's get set up for this bore and we'll get that one sorted out. Righto, that's 100mm deep, and a little bit of wobble on that, maybe about 1/2 mil I reckon, but I've got a 30mm drill that I'll pop down now, and we'll get that cleaned out. That'll be it roughed out, and then we'll look at the other side. Alright, so we started my least favourite operation on turning, and that is parting off. The difference now is that I've got a couple of these proper industrial ISCAR tips. And I used these when I was doing the duplex boilers, when I was parting off the stays on that, and it performed really well. So I'm going to give it a bit of a go on here, and we'll see how it goes on the mild steel. It's a pain, the body of the parting off tool is about to hit the circumference here. Well, I think that's just about through anyway. I'm just going to take that out with a hacksaw. I think it's starting to free up a little bit, so I'll just finish that off. I think it's only down to an eggshell. Well, I might have been able to make it. It was literally 2 strokes of the hacksaw. It was just down to the very thinnest of eggshells, just on the taper of the drill that had gone through. Alright, we'll get this set up, turned around, set up, and we'll start roughing out the other side and getting the bore sorted out. Alright, we'll just face this down. I've got about 6mm I want to take off, and that'll leave me about 1.5 mil left on the depth. And we'll tidy up the diameters here that we need to come down to, and we'll do a rough bore. So that's it roughed out, and then we'll move on to our finishing passes. Alright, I'll set up, get this diameter turned down to within 1mm of final size, and start the bore out. Alright, I'll set up and get this bore done roughed out now. Alright, I'll continue roughing that out and we'll bring you back when we've got that all finished, slightly undersized. Alright, so we've got the hub roughed out now. I've left it about a mil and a half up on most of the diameters and including the bore as well. So I'm going to flip it around, hold it in the 3-jaw, and we'll finish off this diameter here. So we've got a step in here, we've got a thread to cut on here. We'll also do the final bore. I'll also machine the OD to final size. Then we'll flip it around and hold it in the 4-jaw, clock all this up, and then we can do the final machining on this face here, knowing that everything's concentric. So that's the plan. Let's get it flipped over and we'll start doing the machining details on this side. Alright guys, I've machined the 2 diameters to size. We've also machined all of our lengths to size. I've actually tried the hub on here. It's just a light tap on fit at the very end just to get it to suit properly, and I'm really happy with that. What I'm going to do now, before we start our boring operations in here, I'm just going to cut the thread relief while I've got this tool in. So it's a 16 Tpi thread, which is just a tad over 1 millimetre deep. So what I do is I just turn my tool head around, I plunge in, and then I side cut just a couple of mil either side. That gives me my thread running. And that's our thread run out. Alright, we'll get set up to, I might do the boring first, then we'll come back and then we'll cut that thread. Also got to put the 45 on that face as well, on that edge. Alright, we'll give that a measure and see where we're at. I only really need to make sure that the diameter is correct for the length of the bushes on either end. So I've got to do a little bit of lineaging to get that right, and then I can size the bushes to suit. Alright, that's the bore done. That's the bush that's worn, I reckon, by about 1.5 thou. And that becomes a bit of a press fit, and then we may be able to use this one. Yeah, it winds up there. Maybe I'll use this one. If I can get the other one out in one piece, we might be able to reuse these rather than me shining up new ones out of that bit of stock I've got. We'll see how it pans out. I'll do the counterbore now for the sealing. I was going to do it 5/16 deep as per the original, but I'm just going to do a quarter to suit the seal that I've actually bought for it. Alright, so I think we can use this big one for that as well. And alright, let's make a start. Alright, so that's the counterbore done for the seal. It's a little lip seal. And I'll make up a mandrel to get that pressed in nice and sweet. I will cut a little bit of a lead on that before we do finish up. So yeah, very happy with how that's come up. Alright, so next job is we've got to cut this 16 Tpi thread for the lock nut. And once we've done that, we're going to take it over to the small lathe and set it up in the 4-jaw to machine all the features on the far end. Alright. Alright, so we're just going to put a scratch pass into this and we'll see how we're looking. So it's imperial thread. I have a metric lead screw, so I have to leave it engaged all the time and then reverse it back. So let's give it a go. I'll slow it down just a tad more. So I'm looking for 16. Yep, that's spot on. Alright, I'm going to turn the camera off and focus on this because I don't want to miss it and wreck it. So I'll come back when we're done. We've got about 1 millimetre of depth to go. I do know a lot of guys angulate their top slide and then come in, so they're only cutting on one flank. What I do is I go in direct, but then I side shift my top slide slightly so that I'm biasing on one flank all the time. And I don't mind that way. It gives me a direct in as far as the length goes, and I just fine tune it coming down to the end on each flank until I'm happy with the fit. And last cut, or last couple of cuts, hopefully it's just a tiny wafer cut on both sides. Anyway, that's how I do it anyway. Alright guys, I'll bring you back once we've got this done.